Bismillahirrahmanirrahim. In most of the software like eViews, to test the normality, we have tests like Jarque test. But unfortunately in Excel, this test is not available. Don't worry, we can develop our own this test with the help of skewness and kurtosis because skewness and kurtosis functions are available in Excel. Uh, for normality test, basically the assumption is that this is basically assumption of classical linear regression model that our residuals or series should be normally distributed. So it is our null hypothesis and alternate hypothesis that the series is not normally distributed. So in all diagnostic tests, usually we want to accept our null hypothesis. Now let's start that how we can test this Jarque test. Basically, how we can use this Jarque test in Excel. Here we have the data. Uh, One is DV, that is price, and we have three IVs: mileage per gallon, weight, and length. Now go to data, then data analysis, select regression, your DV first, then three IVs, because we have selected with labels. So we should check this label box. Then we want to check it on 5% level of significance. And then we need residuals as well. And we want output in this sheet as well. So select cell here, F1, and press OK. And now just check the results. All the IVs are two IVs are significant, weight and length. Here we need just residuals. So just copy these residuals to the next sheet. These are basically residuals. Now first we calculate number of observation with the help of count function, because we need these number observation in Jarque test. Then and now look at Jarque test. It is basically number of observation multiplied by skewness square divided by 6 and plus kurtosis minus 3. It is basically excess kurtosis. That's after taking square, that is divided by 24, we will get Jarque test. Now it means that now we calculate skewness. For skewness, we have skewness formula. Use this skewness population function formula and press tab. Then calculate excess kurtosis, because in Excel we don't have kurtosis, we have only excess kurtosis, so we calculate excess kurtosis with the help of this curve function. Now we can get kurtosis by adding 3. Now look at the formula. We need skewness square in the first formula that is originally developed by this researcher Bera, and it is modified form. Here we have mentioned excess kurtosis because after subtracting 3 from kurtosis, we will get this formula. So we need its square. So just take the square of skewness as well as skewness, kurtosis, and excess kurtosis. Now, look at the first formula. We should have total number of observation. That is multiplied by skewness. Skewness here skewness, we have taken R square by 6 plus kurtosis minus 3. Here is this is basically kurtosis, and 2.95 is kurtosis minus 3. It's power 2, and that is divided by 24. I think there is mistake in the formula. Let me check again. Yes, its power should be 2, and now it's okay. Now, second formula. In second formula, we have excess kurtosis, so it is very easy to use. Again, number observation multiplied by skewness square divided by 6 plus excess kurtosis. We have this excess kurtosis divided by 24. No, it's both of them are giving the same answer. Now to check the significance, we can check its significance with the help of critical value as well as p-value. Now for critical value, chi-inverse function. This chi basically Jarque test follow chi distribution with 2 degree of freedom at 5% level of significance with 2 degree of freedom. Now, here you can see that as Jar-Bera test is not greater than critical value, so we fail to reject null hypothesis. It means that we will accept H naught and conclude that series is normally distributed. We can check it with the help of p values as well. So chi this function, and it is a calculated value of Jar-Bera test, and then with degree of freedom is 2. Again, you can see that we have 0.06. So it means that it is not significant at 5% level. Again, we will accept our null hypothesis. And you can even compare this test with the output of E-views. It is the same. And you can say that here the p-value is 0.064. Thank you very much for watching this video.